We've developed a way of generating aligned carbon nanotubes as emitters in what's called a spent cathode structure, which involves a pit with carbon nanotubes well aligned in the center of that. The devices we're making emit electrons through what's known as a field emission process as opposed to a thermionic emitter. There's several different applications. One can be for traveling wave tubes for microwave applications. The other is a Hall effect thruster, which is a type of satellite propulsion that does not use combustion like rockets like you're usually used to seeing. It uses, it's what's known as ion electric propulsion. The third application is space tethers, which is a way of raising or lowering an orbit of a satellite without really any propulsion mechanism at all, just merely capturing energy because of the Earth's magnetic field. And then this application with the Alice CubeSat is to study the plasma environment around the spacecraft. CubeSat is a very small satellite, about this size, roughly 10 centimeters by 10 centimeters by about 30 centimeters. The Alice payload consists of two different parts. One is the Electron emitter that we're manufacturing here at Georgia Tech, and that's the carbon nanotube-based cold cathode. It's several small little chips that are about the size of a dime, about a square centimeter, and we've provided to AFIT maybe 24 of those, and out of those we wanted to find 4 that were very closely matched. 2 of those will ride to space, 2 of those will stay in an identical satellite that's here on the ground, and we'll compare the conditions between the 2 in space. One is in an enclosed environment and one is exposed to the space environment with the 2 that we have here on the Earth to see if there are new degradation mechanisms that come into play from atomic oxygen or micrometeorites. The other part is the IMESA sensor made by the Air Force. It detects the plasma environment around the spacecraft and is useful for predicting impacts of the space weather on the satellite. Well, we're pleased to work with AFIT, who's the Air Force Institute of Technology, to provide this payload. It's been great working with them.